Thanks all for coming. It's a small group, so if you have questions along the way, especially if I can clarify something, please let me know. It's only 10 slides, probably more words than I'd normally like to have, but feel free to fire away, and I hope we can have perhaps some discussion as well. So to just lead things off, here's a figure that's part of a homework assignment that's out in the wild right now for the graduate students to work on. This is mobile radar research data looking at about 3 kilometers of vertical depth in the atmosphere. And this is a little patch of a larger scan that was taken. And this is the sort of thing that I've been trying to build capacity in among the atmospheric science graduate students to be able to take research grade data from various sources and work with it with modern tools in a way that supports not only their education but also the research activity that's ongoing among the faculty in the department. So I'll start with a thesis, which is kind of repeated from my abstract if you read it, and that thesis is that well, some Research One campuses across the United States have a mature heritage and even an agenda-setting role in a culture of scientific computing. Texas Tech is still growing in that regard, I would say, and it's one where any communities of practice for scientific computing tend to reside within individual departments, and growing beyond that sort of sole faculty effort or departmental level activity, I think is a place where Tech could grow, grow culturally. So I asked the question, how can we maybe accelerate building that capacity and culture for doing scientific computing in a way that is nationally and internationally relevant? And I've kind of made that one of the emphases of the early part of my career here, which is to focus on our atmospheric science MS and the PhD students that are affiliated with atmospheric science faculty, and try to focus on improving our scientific computing capacity for those students. So the ATMO graduate program, just to give you a sense of the size, there's 7 atmospheric science faculty in the geosciences department, and that serves about 20 masters and 5 PhD students. That fluctuates a little bit, of course. And all of us are fairly research active, and so we deal with lots of data. We maintain a strong research link to the National Wind Institute Interdisciplinary Center, which is a home for shared technical and technician resources that any one department wouldn't be able to afford on its own. And this notion of some sort of shared resources and going beyond what individual departments can do is a notion I'll return to in a little bit. Let's see. So high-level goals of what I've been trying to build into this scientific computing capacity. One of the things I wanted to do when I first started here was to build in computation in the Python language in my case, and build that into course material as part of homework. So, for instance, students should be able to read data formats like that weather radar data or numerical weather prediction models that are run in the HPCC, and be able to use those data sets as part of homework, combine it with theoretical concepts that we're learning in the coursework, and implement those calculations in code and visualize those. And so that adds a sort of practical flavor to the coursework that builds some skill. As we're doing that, that's also going to support the faculty and selfishly my own research program in building the capacity for using those tools that I need and the rest of the faculty need the students to be using to be working on discipline-leading data sets. So I'm interested in things that are not just toy problems, nice simple things that work smoothly, but actually helping them encounter some of the real challenges as part of that homework kind of approach. And when I started here about 10 years ago, that student population really didn't have the skill or the background in doing those sorts of things. That has improved with time, so now I can jump into the first assignment in any course, and I don't need to train them on basic computational mechanics. So I don't have to teach them what an array is anymore, and I don't have to teach them about a for loop. And obviously that allows us to focus on higher level problems like how do I structure my code and how do I conceive of best implementing this calculation with arrays of data. Another thing that I think has helped is that the undergraduate institutions from which we recruit have modernized their introduction to computing coursework. So historically that used to be a lot of learning to code basic loops in Fortran and doing things like that. Pretty common. Fortran is still very widely used in atmospheric science actually. But that has shifted over towards Python in recent years, which is a little bit higher level and a little easier to get results and plots going, and that's also helped as maybe some younger faculty have started to sort of shift towards more introductory computing material that's research relevant in those undergraduate institutions. And as part of that increasing the skill set in the student population, we've also been mindful of that when we've been recruiting. So we look for programs where we know faculty are doing that kind of work and where recommendation letters mention scientific computing skill or even just interest. Getting students interested in the problem in the first place is, as many of you know, can often be a big problem. And finally, as we've sustained this effort over many years, that leads to institutional capacity that resides among the graduate students. And so they can do that sort of peer-to-peer teaching and educate one another. And I think that's also helped me not have to teach people about what a for loop is and what an array is, because they just go to their neighbor and they ask. And so that becomes a sort of cultural thing that that's there among the graduate student population. In support of all that, though, I've also implemented a variety of different sorts of training activities along the way that have also helped. And these have largely taken the form of workshops that are focused on teaching practical skills and also introducing students to sort of new horizons at in say Python, and new packages that make some tasks that you used to implement yourself just a standard operation that you can leap ahead with. One of the reasons I've chosen these workshops, which I'll describe in a moment, is that the actual curricula in just about every science program I'm aware of are pretty much full. But if I were to imagine sort of teaching from first principles, what a student would need to know to be effective at scientific computing, I would probably need something that's about the length of a calculus sequence, right? I would want to build up from scratch with for loops and arrays, and we would practice gradually with time. And I just don't see any meaningful way, or I don't see it's reasonable to spin up 3 or 4 courses and add that to the curriculum. So these workshops are a sort of shortcut where we focus more on teaching by example, introducing some sort of baseline of high-level tools to say, use these pieces and you'll be headed in the right direction. And we're avoiding fashionable buzzwords, so it's not like, here's my workshop in machine learning and artificial intelligence. It's, here's my workshop in numerical Python arrays and the plotting library you should use. And we're also not focused on low-level CS concepts, so I'm not teaching them database theory, and I'm not teaching them what a linked list is, because that doesn't, they're not going to connect to that anyway. And they're probably not, they might use it, but they'll use it how it's implemented in Python instead of as a concept they'll implement themselves as a CS student would. Okay. So overall, this has a sort of practical focus, automation of workflows, dealing with certain data formats. And this has been set up, I've done this activity, held a workshop pretty much once a year for the last 5 years or so. And these are done as sort of intensive 2-day, all-day workshops. So you sort of sit and marinate in the computing as a student for those 2 days. That's obviously challenging to find a time that works for everyone, and I still experiment with that pretty much every year when I try and do this. It helps that I have a pool of willing and directable participants in the APO program that I can sort of use to serve as the bulk of these workshops. So for basics, I've used the Software Carpentry program, which I'll describe on the next slide. And then I'll also talk about some of the discipline-specific workshops that are focused on maybe some more advanced tools and directly applicable to atmospheric science. And then beyond these local workshops, I've also focused on these horizon broadening activities through participation in national or international open source communities of practice. And that's both at the American Meteorological Society's annual meeting, as well as the SciPy conference that happens down in Austin. So I'll talk about that more later as well. This has been supported, and I certainly want to acknowledge the National Science Foundation for the support they've provided as part of my career award to facilitate external instructor travel and student participation in these conferences. Obviously, it takes resources to do these things, and so that's the source of that support in this case. All right, so Software Carpentry is part of one of the Carpentry's workshops. This is a nonprofit organization that has, that, as it says on the screen there, teaches foundational coding and data science skills to researchers worldwide. This was started by Greg Wilson and is now a very large international effort. The blue dots there are everywhere they've taught a workshop worldwide. You'll see dots there, a dot there at Texas Tech, and that's me. They have software carpentry as well as a library-focused program, as well as things that are a little bit more data science-focused, which is the data carpentry's thing. And let's see here. It's a nonprofit organization and really focused again on this sort of pragmatic angle that's taught with these community-developed and maintained materials, which means that they're sourced from practicing scientists instead of computer science faculty or other sources. So that carpentry idea is kind of evocative of the process. If you're going to learn your toolkit to be able to construct some software. For instance, the Introductory Software Carpentry workshop basically goes through sort of 4 half-day chunks, and they focus on the Unix shell and version control. Those are sort of must-dos. And then the other sort of full day is spent on the basics of Python as used in scientific computing. So this is sort of good basic skills. It's the sort of things that were lacking when I first started at Texas Tech in the atmospheric science student body. The nonprofit organization itself is a very active program. One of the things that it does is it provides intensive training for the instructors, who are then paired by the organization with institutions that want to run workshops. So they facilitate all of that training side of things. It's also strongly informed by pedagogical theory, and so they do a good job of giving some basic pedagogical instruction to their trainers, so that when they go into a workshop, they're very effective. The organization also has a significant focus on diversity, equity, inclusion, and accessibility. They have a code of conduct. This is becoming common at a lot of conferences these days, and it has a similarly diverse leadership team. So that's definitely a positive as well. And if this sounds at all interesting, for those of you that are interested in institutional priorities, they do have institutional memberships that are available and some requirements that are attached to that. But I'll point that out and can visit with you more about that later. They have a good website that describes all of that as well. All right, moving on from software carpentry to atmospheric science. Every discipline has its own sort of data sets and visualization methods and oddities that it needs to account for. And so here's a weather map showing, let's see, this is the 296 Kelvin Montgomery stream function, wind, and relative humidity over the continental United States. Plots like this are pretty common. It's a weather map, but a research weather map. And in order, as this initial population of students went through software carpentry, I began to realize, oh, well, we now have this body of second-year students and PhD students that still want to keep learning. So we've sort of alternated the software carpentry workshops with these atmospheric science-focused workshops in order to keep the more experienced students interested. In this case, we've partnered with Unidata, which is a NSF-sponsored organization whose mission is to make meteorological data available and accessible. That includes real-time and archived data feeds. They develop tools that allow you to access and use those feeds, as well as discipline-specific packages for calculations and plots. And they even make some upstream contributions to the open source projects on which they're building tools. So the plot that I showed you to start out this slide is from the MetPy package, which is one of the packages that Unidata maintains. If you have worked with atmospheric science data at all, and possibly data from some other fields, you may have run into NetCDF. Unidata are the folks that actually are responsible for developing and maintaining this NetCDF data format. NetCDF is a way of storing arrays of data, multi-dimensional arrays of data on disk with variable names and an idea of shared dimensions across those arrays, as well as metadata. And so it's actually a great data format that is useful in many, many disciplines, I would say. Right now it's built on top of HDF5 with a certain use of the HDF5 format. Anyway, the Unidata's there, and several of their staff are also trained as these as software carpentry instructors, and out of that effort, they've also developed a similar set of lessons that are tailored to atmospheric science. And so we partnered with Unidata to come in and help us instruct these workshops and expose our students to the wider atmospheric science research community and the resources that they'll be taking advantage of as they grow through it within the profession. I already mentioned that some of the data formats like NetCDF and some of the open source tools that we teach during that are also useful beyond atmospheric science. So I've had participants from outside atmospheric science, even in these Atmo-focused workshops, because, for instance, this is the Python matplotlib plotting package fundamentally under the hood, and so there's folks in biology or physics or wherever that might use that. So there's a list of some of the Python packages that we talk about. If this sounds interesting to you, I'm running one of these next week. We have 2 instructors coming down from Unidata and a 3rd instructor from outside. It'll be Wednesday and Friday of next week all day. Each morning we're going to do tools, workflows, and principles for structured data analysis in Python, focused largely on this set of tools I've listed down here. And then each afternoon we're going to try something new this year where we have a sort of bring your own problem, sort of small group help session type format where some of the things that I've noticed our PhD students keep encountering are going to be discussed and worked on, and people will be able to receive help with their own problems from some expert helpers. So we'll see how that goes. If you want to join, there's limited space in the room, but plenty of space right now. There's a horrible URL here for you to visit that I didn't have time to get a real URL for. But send me an email and I can just send you the link, of course. We'd love to see you. I already have one student from computer science that's registered, and so we'll see how that goes. It's usually a lot of fun. I also mentioned the AMS and SciPy conferences, and these are really, I really targeted these kinds of things, especially SciPy, at our PhD level students who have an interest in scientific computing and have developed this palpable sense that someone's probably invented a tool to solve their problem, and they want to go hang out with a bunch of those people for a week to figure out what tool they should adopt and what the frontier of scientific computing looks like. So this photo here is actually from one of the plenary sessions at SciPy. It's held every summer in Austin at the AT&T Executive Conference Center. It is it's probably actually the favorite conference that I go to, even though it has nothing to do with my core work as a lightning researcher. But obviously I enjoy the scientific computing stuff, and it's really neat because you have the developers of all of these open source libraries that you're using are there in the room, and you have people leading many of these efforts, both from academia and industry, and it's again a very sort of practical conference where you have 2 days of tutorials and then a regular sort of 3-day conference, and then 2 days of code sprints at the end where you just get to hang out with your friends and either contribute to an open source library that you're using or work within your discipline. There's often little clusters of like geophysicists that hang out, or ocean scientists that'll hang out, or atmospheric scientists. Oftentimes we're in the same room together because there's not that many of us at the conference, but we'll hang out and work together on problems of interest at that meeting. And more broadly, the American Meteorological Society has also started running a Python symposium every year at their major annual meeting. And that's a meeting that all of our students are going to pretty much every year anyway, so it's another opportunity we point them towards to either give a talk about a tool they've been working with or another place for them to learn. And I think SciPy is a really sort of huge boost to me when I go kind of every other year. I take all the PhD students that haven't gone yet, and we all drive down to Austin and go hang out for a week in the middle of summer, which is pleasant. The student that was on crutches one year did not enjoy his time physically, but mentally he enjoyed it. But it's a huge boost, and I enjoy having an opportunity to stay connected to this sort of frontiers of pragmatic computing in the sciences. And I think this is maybe a piece that can easily get missed, but the culture and context of the community in which you're doing scientific computing is, I think, really important and a really important part of making smart research choices, so that you know that you're at the frontiers and you have that confidence and a set of resources beyond local resources to draw on for doing your research. And I find that in the end I wind up saving time by going to the conference because I can adopt solutions that others have already implemented. So an example of that is I went to a machine learning tutorial last year that was just extremely well taught. It built off of least squares regression, typical line fitting like we all do all the time in the sciences, but then generalized that concept of optimization towards machine learning and neural networks, so that by the end of that, it was like, oh, I understand kind of how that whole framework works now, and I can understand how I would apply that to an atmospheric science problem. Let's see, I guess this is maybe the slide that might promote the most discussion. Let's talk about some local structural factors that make it challenging to do scientific computing. Texas Tech is isolated in the Southern Plains, no news there, and thinking about this practically, I have a colleague who came from Harvard and MIT, and so in the Boston area, there's this whole network of universities and practitioners that you can draw on, even if they're not within your institution, to learn from, and I don't know, maybe you have a beer with them and just get to talking about things that you might not otherwise encounter. And for us to do that here at Tech, right, we have to make a 5-hour drive just to get to any other major metropolitan area. So it's very hard to develop those sort of informal and highly tailored and discipline-specific networks that you might otherwise rely on if you were at a different institution. I actually like working here quite a bit, but this is something that I have to work to overcome. Also, as I stated in my earlier thesis, I want to return to this idea that Tech is kind of this newer R1 research university, maybe a baby R1 is sort of how I would describe it. And we're still sort of developing a lot of this computing culture, that other institutions might have developed over the last many decades, and that's not easy to catch up with. And many of these universities that I'm thinking of are universities that literally helped invent and pioneer the way the internet works and invented this open source culture. So, for instance, macOS, the laptop I'm running on, and my iPhone in my pocket are all running the Berkeley software distribution of Unix, a derivative of that. But that work was done in the 60s and 70s at Cal Berkeley, and that's now had this massive impact. But that's the kind of heritage that many of these other institutions have and that they're working with. I don't expect to have that here. I think that would be unreasonable. Again, it takes decades to build that. But it's also interesting to think about that history and what sorts of things we might need to catch up on that we aren't doing otherwise. Because that doesn't come about just because you have enough PhD students and grant funding per year within the university. And keep in mind too, those are the institutions that are continuing to lead. They're pioneering data science curricula. There's large 200-person lectures at Berkeley, for instance, that are in an Introduction to Data Science course. And they're learning all of these Python tools that are taught in Software Carpentry as part of their first course in a program at the undergraduate level. The Moore Sloan Foundation has funded these data science environments at New York University, Berkeley, and University of Washington that are also supporting a lot of these sort of core scientific Python packages. If you've used Jupyter Notebooks, that whole team is actually housed at Berkeley, and the guy who invented IPython is actually on the statistics faculty there now. It's not really something that NSF or the federal agencies are reporting. It's actually foundations that are supporting this because it's, well, I'm not exactly sure how they convince the foundations to support this, but they recognize the value of these tools for the wider community and that it does need support. So, let's see. Another thing, I had a colleague in physics who's since moved on to another university, but one of the things he pointed out was that he was surprised when he got to tech that there were no hack days or computing clubs or, thinking more broadly, there's no nationally visible players in open source like you would have at Berkeley or Washington. And so, again, it's hard to sort of locally figure out how to get involved in that culture here. Maybe on a more hopeful note, actually there's an alumnus from the mathematics program here who is now president of NumFocus, which is the nonprofit that supports the key open source scientific computing tools in the Python ecosystem. He's now funded full-time by the Sloan Foundation to run that institution, to be a steward of these open source tools that now have a huge maintenance burden because they're so widely used, but no real full-time employees maintaining them because they're open source packages. So that's kind of an interesting connection there. I saw him at SciPy this summer, and he shows up there, and nice to chat. I want to say a little bit about just sort of resourcing within Texas Tech, again, because we're still developing this culture of being a research university. I would say the departments, centers, and programs are often under-resourced and struggle to provide scientific computing specialists that support domain-specific software. So meteorology has the WRF model, and it has all of these, has the MetPy package, and we often are doing a lot of stuff on Linux. And having someone within a department or a program, or even like a little research data center that's dedicated to that program is fairly common in the meteorology programs at these mature R1 schools. I don't see a great deal of that around tech. I think university IT policy doesn't help that a lot. It's focused on buying and procuring standardized solutions, and is probably not really set up, nor does it really even care to invest the time in efficiently and responsibly facilitating what I would call sort of weird skunkworks projects, which are the lifeblood of the research activity at the university, but are supremely non-standard. So I think that's a place that tech could maybe perhaps reorient itself institutionally towards opening up those kinds of opportunities. I have specific stories if you want them. Overall, I guess what I would say about these local structural factors is that they require some sort of conscious and steady effort, and it requires breaking out of the we'll do what we can with what we have locally mindset and just continuing to push on it over many, many years, and you can make progress. And I really enjoy what I do now on a daily basis, and have enjoyed the process all along of doing this, but it definitely has taken some effort on my own, and support of colleagues and whatnot, but is not something that the university blessed me with like a fairy godmother. So I'll close here with these few points. In summary, to be practical about it has worked really well. I'm not coming here to ask for a university initiative in scientific computing, in part because I don't think that will really help. I think what would improve Tech's scientific computing capacity would be less focus on making Texas Tech great, which I do want to have happen, but paradoxically we do that by focusing on sustaining these external connections and participating in this national and international community, and we focus here on the pragmatics of getting work done. So within the atmospheric science program, I have a small faculty cohort and a cohesive student body who all sort of share the same kinds of problems that they need to work on, and so we can sort of recommend a common tool base for them and include that routine practice for them that allows them to really develop these skills instead of just doing a sort of one-off course and hoping that it all turns out okay. And I think I've seen benefits of that in accelerating the research among the AMO faculty. I think it's also interesting to think about that there are these tools that are generalizable. A lot of the sort of core scientific Python libraries are now very widely used. And I've made some effort to advertise to the wider Texas Tech community with folks that I know. STEMCore did a nice job last year of blasting out some messages, inviting people to the workshops. And we had some takers from the wider community, but it's been very mixed, and people are maybe not sure what to do, or maybe I'm too focused on Python, but I think that's a pretty good choice for the sciences. So I'm still kind of wondering, like, where are the people at Texas Tech who love code and data? I know the HPCC folks do, but that's not an academic program. There's actually a group I just learned about over in biology that's been running a seminar course each semester, and they're oriented exactly as I am. I'm giving them a talk on Friday about some of the stuff I'm using in atmospheric science. So I guess I'd love to see more conversation and interaction with other groups like that in the future, and close by inviting your comments and thoughts about how we might do more of this for the rest of our time together today. Thanks.
I have a number of comments and questions. This could be expected.
Yeah, I bet, yeah.
So for those of you who don't know, that we do have a high performance computing center here. I manage it, and Dr. Tom Brown recently joined us, a former chair of this computer science department at Eastern New Mexico University. We have two other PhD staff and a couple of master's degree folks, and that's all. Well, an administrative assistant and some students. That's what runs the high performance computing here. It's a tiny group. We nonetheless support $20 million of the $70 million of research funding with the university last year, including some folks in atmospheric sciences. My first reaction is I'd really like to have you come and give a talk, the exact talk you just gave to our HPCC user group meeting.
Sure.
I think I'd also like to point out that we did have, probably during the time period that you've been here, a very active weekly seminar program on scientific computing that was organized by Dr. Hassa at chemistry, and he basically just got too busy to do that, and that hasn't been active for many years. So I can certainly see some resonance with what you've pointed out about trying to get groups like that going. I just basically agree with a lot of what you had to say. A couple of things I can just mention anecdotally. Also, a few years ago, we had, about 3 years ago, we had a regular set of Docker meetups here, which actually drew people from the local community, including a developer who I met on a plane just a week ago, 2 weeks ago, headed somewhere, who is now working for a major software development company. It was organized by one of the graduate students that worked with us. So I'd say, in little bits and spurts, we've had some elements of what you talked about.
Yeah.
I also think that these are all just really good ideas, and that I'd love to see, us water this a bit.
Yeah. It seems like there's got to be enough people around,
Yeah.
and so it's like, how do you get that boulder pushed over the hill to where it actually has momentum and isn't reliant on one faculty person, running the seminar series, for instance, like you described.
So I'll ask a question, because I could, give opinions for long periods of time, and I won't. But,
Sure.
you mentioned several software tools, including Dask, which is a personal hobby of mine. So, of those, how many are already supported on our systems? How many do you need installed? Is there a way that we could help facilitate your work by making these things more available on our system?
Yes, there is a very specific request in that regard, actually. There's have you heard of the Pangeo effort?
No.
And Dask Job Queue?
That's job queue, yeah.
Yeah, so Pangeo is an NSF-supported thing. A faculty member at Columbia was funded to do this. It's a complete stack of recommended tools for working with pretty much any data set that's in that CDF format. It was focused on climate data sets, but the vision is broader than that. And as part of that effort, they went to the NSF supercomputer for atmospheric science in Wyoming, the Cheyenne supercomputer, and came up with a complete stack of software that now runs on that environment that allows Dask to be used as part of Cheyenne, including like notebooks and the Jupyter notebooks and that whole environment. So one of our graduate students actually managed to get most of that, I think, running at on Rothgar, or not Rothgar, it's now Quanah. We'd love to have that implemented here locally.
Okay, for those who aren't spending all their time in Python, how many of those are there here?
Me.
Okay, so Python is essentially a scripted language. It can be quote unquote compiled, but it largely was written as a utility kind of thing. Really make a lot of operations simpler to understand programmatically. It doesn't play particularly well, it didn't originally, on the kind of bulk computing we deploy. We have, right now, actually probably about 20,000 cores of computing, and we like to run a so-called parallel style where you really get all the cores possible to work on a problem at once. Python just, by its design, didn't work particularly well that way. And these tools that Dr. Bruning has mentioned have been specifically designed to bridge that gap, to make it more efficient to run this kind of easy-to-run programming language on, big bulk machines. Our new cluster that we're planning will have 128 cores in a node, a single node, half rack unit. If you're running a job that's just using one of them, you're just basically wasting it. So it's really important that we get this kind of knowledge out that he's talking about.
Yeah, there was a good talk at Sci-Fi actually given by one of the Cheyenne supercomputing guys about their experience setting it up and some of the user authentication stuff, and basically the whole thing that you have to do when you're doing it as an institution. And so I can point you to that talk and maybe connect you with the folks that can give you pragmatic experience and advice on doing it here.
So one more and then I'll stop, but just, you mentioned Jupyter. We support Jupyter on our systems, but it's a little bit obscure to get it to run. We don't exactly have a user guide for it. If you know what you're doing, you can get it to work and we'll answer questions. But one of the things Dr. Brown is working on is trying to create a framework for a much easier method of accessing Jupyter Labs here through a web portal and everything. So kind of modernizing our, these days, almost every field of study uses computing. And certainly every field of study uses data in some way. So, I mean, try to imagine making a movie without a computer these days. So, it's really important that we stretch out from our, comfort zone of command line oriented scientific computing into stuff that people can access.
Yeah, and that whole Jupyter Lab environment was also done on Cheyenne, so that's the user access part. There's a whole login thing, and maybe you've encountered some of those pieces more organically along the way, but I bet we can help jumpstart that by getting you talking to the right people. And,
Yeah, we've got some tools so it might be beta testers, isn't it?
yeah, I know we have some of our grad students involved in that.
Sort of a comment, I don't do anything related to computing, but thinking of how you might try to find everybody on campus, right, that's doing it. So years ago, out of nutritional sciences, they started an obesity research cluster. And it started with a half-day symposium where they advertised well across campus. And there had to have been, because I went to it, there was easily 100 people that showed up that were tech faculty interested in doing research related to obesity some way. And there were presentations that were given, and now I believe that it's gone from being a cluster, so that was 5 years ago, to now actually being like an office or a center. Is it a center? A center for obesity research,
Okay.
like on campus.
Yeah.
So perhaps a way to do this would be maybe through the HPCC, in conjunction with you, and if you needed STEM course help, right, to broadcast this out to campus, however. But maybe having a half-day symposium and advertising it for people who do this kind of work, and just bring everybody together, and you start some sort of research cluster, and maybe you try to do a seminar twice a semester, or you meet once a month as a group, so that you can find the people on campus, because they're there, but they may be like you, they're just in their silo and they don't know. We're really good at doing that, especially on this campus. And then the other option would be to having a conversation with the VPR, with Joe Hepper. Because his office is aware of what other people are doing, right, the other researchers on campus. And it may be a way to start to figure out who some of the key players are that you don't know because like you just discovered the people in biology.
Yeah, right.
So those are some ways that you might think of trying to pull people together. Because the obesity research cluster now, they've gone after all sorts of federal funding, and now it's a center for obesity research, but it all started because there were a few handful of people that were like, hey, I'm interested in doing research related to obesity, and it took off from there, so.
Yeah, and I can see that working well, because you can easily make a case, and you can make a case to the VPR that, like, we're gonna go after grant funding because we're getting together, so support us. This is a little bit more meta level.
No, I know,
talking
but
about, and so.
But even like pulling people together so you can find the other people on campus.
Yeah, that definitely
That
sounds
part,
useful,
you know.
yeah.
But you never know, it's research, so.
Yeah.
I wouldn't discount, he's very open-minded, that not everything has to translate to, hey, that's gonna be like dollars that are coming to here.
Yeah.
If it's going to raise the profile of Texas Tech in any research-related capacity, right? And what you're doing might actually improve the computing capabilities for people that do go after. It may not be all of you going together in one, but it'll help you if things are improved when you're applying for NSF grants, right?
Right.
And the same thing for the people in biology, and the people in computer science. So I think there's a way to market it to him. He's very open-minded, but it could just be something starts through the HPCC first, that a half-day symposium, a day symposium, just to pull people together.
Yeah, getting back to doing the scientific computing seminars might be helpful.
Right, like that, something like that
I
would
was
be
very
great.
intrigued by something you said about leveraging the professional staff, though. It's been an idea of mine for a long, we have a tiny group. It's not gonna get bigger, we're trying to be very efficient. So one way we could help bridge the gap is to recognize that IT support well, especially scientific departments, but pretty much all departments can play a role here. It's no longer just fixing your printer, right?
Right.
These days, we could train those people on how to use the resources here, and then they can be the local consultants. There's actually a whole program to do this in an organization that I work with called the Coalition of Advanced Scientific Computing. They spawned an effort called this Research Professionals. And so basically, the idea would be to have these, to include these IT support people in departments. Those, I know several who would probably love to get training that they could then use to help facilitate activities in their departments. So it's a way of making maybe our group effectively bigger by connecting with professional IT folks in the departments.
Yeah, and that would be an ideal sort of organizational connection point, because then it's attached to a research-minded management structure as opposed to a Windows, Wi-Fi, and security-minded management structure.
So then how to do that, you know, we could imagine having some sort of certification that might add to their professional resumes. It might be, you might work with the departments to, you know, make a salary incentive there, you know, stuff like that.
That would work, and I think also maybe some of that for some of the staff might be enticing. For some of the other staff, you know, they might not want to do that much professional development at that stage in their career, and so maybe university-wide some dean-level type support for a second research-minded computing person within these departments, I think would be wonderful. I have this is the connection to Wind that I didn't quite get around to mentioning, but several of us have been able to pool money to support a Linux sysadmin type person that takes care of some of our resources there, but are only able to do that because we're very research productive, have grants, and can, you know, pool that in some way to get that person supported.
Right, but if we were to take those people and train them, for example, in the methods that we prefer to see people use for moving data, for installing software, stuff like that, we could serve as a training base for those people and then improve the research practice throughout the university.
Yeah.
For example, we have very specific ways that we like to move large amounts of data. They're highly efficient, they're much more secure, but most researchers only know something that they learned in grad school, like SCP or something like that. And, you know, we can teach them better methods that will work right on your desktop and handle huge amounts of data.
That would be great. Do you see it within HPCC's mission to also support staff that are not necessarily interacting with the HPC systems? Because that's another component of it.
So our basic mission is to make the research community more productive. And we deploy computers as the main focus of that because we're more efficient at it. We spend, you know, people these days say, oh, I'll just do it in the cloud. But we spend a small fraction of what it would cost to buy that same amount of computing in the cloud. And we're able to be more connected with the research practices at other major universities and, you know, bring those tools by just interacting with people through organizations like the ones I mentioned earlier. But I do think there's a potential gap growing between that and the just getting started level that you're very usefully working in.
Mm-hmm.
Because if incoming students don't learn good practices right away, you know, you're going to spend all your time making up that ground, trying to get them to unlearn inefficient ways of doing it, learn more efficient. So there's really a huge amount of value in what you talk about in getting right into the beginning levels. And that's an area where you don't have to be an HPC expert to get involved. You could just help with some of this organization.
Andrew, is there any way you have the introductory seminar that's mainly web-based, that's really good, that's been offered twice a semester or twice a year, of taking it, not going to the full carpentry, but the next step somewhere, you know, a second more advanced than the intro that the HPC offers and the full carpentry step? Because I see that as, you know, there's enough information on that on how to get onto Qunar and Rothgar.
Yes.
But there's then that next missing
Yes,
step.
I'll give an example.
And
a
that
few years
used to be
ago
in
we
the
had
old seminar series,
Right.
it was excellent.
Oh, it was. And we've had some transition, of course. One thing we lost was that I used to have my job, Phil Smith, wonderful guy,
Yeah.
used to teach
He
an
used to teach
introductory
there, yeah.
class, and he was a tenured professor at math and introductory parallel computing. And when he left, people started calling me up and saying, when are you going to offer a class in parallel computing? But we were busy, so what we did was we fell into this partnership with the Exceed collaboration where we run the monthly, Tom is the one who runs them now. It's not a webinar, it's a real classroom experience delivered by
Yeah,
video.
something that fits in between the two
Right.
levels.
So I can see that
Yeah.
following that pattern is something we could, if we had a partner to work with. So if you could help facilitate these carpentries things, we could advertise and get people to them. There is definitely a demand, but like I say, we're a tiny group, and
Yeah.
midnight comes early, I will say.
Yeah. And I think that's something all of us face, and that seems to be one of the hurdles, is that someone's gotta take on the burden of doing it. The carpentry workshops, there's I think like a $5,000 fee that the organization charges to facilitate that, and they have some assessment components
Sounds
that are
worthwhile to me.
part of that. And then there's some, small travel expenses and that kind of thing, but you're talking less than $10,000 to put on the workshop, and you
Oh,
can
yeah.
charge a registration fee. and all that.
Definitely money well spent. So one story I'd like to tell in the way of the value of this kind of broadening efforts comes from Berkeley, in fact. This was several years ago. They had the usual problem that budget time, their high-performance computing outfit, which was 100 people, by the way, much bigger outfit than ours, was facing the problem that budget time, the engineering and sciences deans would always defend the computing budget, and the other colleges would often argue with them. So almost as a defensive measure, they started hiring people who knew computing, but with backgrounds in completely other fields, English, psychology, music. And they got to the point that about 10% of their staff was this kind of person, which, is more than my whole staff. But the effect on the program over 2 or 3 years was remarkable. The number of users of their computing center went up by a factor of 10. Not a factor of 2, not 10%, a factor of 10. The diversity in every measurable parameter, the field of study, age, gender, demographics, all those numbers just improved. And most importantly, the deans of the other colleges stopped arguing with them about their computing budget as much. So this to me was a huge demonstration of something that I've felt for a long time, which is that the challenge is there. Computing is needed in a wide variety of fields, almost every field of study. Somebody is going to need computing, and certainly somebody's going to need data. But we have to figure out how to rise to that challenge, and it's a big challenge. But what I do think we can do is demolish the idea that you have to start only from the technical end of that problem. It's largely a social and a people problem.